Let's start with absolute basics of integral calculus. Think of integration as the exact opposite of differentiation. It's like a rewind button for derivatives. If you know how fast something is changing, integration helps you find the original function, which is why we call it antiderivative. Because any standalone constant number disappears when you differentiate, we always add a plus c at the end of an indefinite integral to account for that missing baseline number. So integral of f of x dx equals f of x plus c, and the constant is added because it is an indefinite integral. So it is an arbitrary constant c. So it will represent all possible original functions because it's an arbitrary constant, right? Moving on to the core methods of integration. So when an integral isn't simple enough to solve by basic inspection, we rely on three fundamental techniques to break it down. First is substitution, where we change the variable to make a complex equation look like a basic standard formula. Second is partial fractions, which takes a complicated polynomial fraction and decomposes it into simple algebraic pieces. Finally, we use the integration by parts, which is our standard baseline tool whenever we are faced with integrating two functions which are multiplied together. So next is we move on to the definite integrals. While indefinite integral gives us a general formula, a definite integral has a specific starting point A and ending point B, resulting in a single fixed number. Geometrically, this number has a fantastic meaning. It represents the precise area trapped right underneath the curve of your function, sitting perfectly between your two boundaries on the graph. So that is the notation: integral f of x dx from a to b. A is the lower limit and b is the upper limit. So it will evaluate to a unique numerical value. So this is just the basic explanation. Not much formula is used in this right now. Maybe we'll make some more videos in detail because this is a long topic, long chapter. So the area can be calculated, and that is the geometric meaning. So the fundamental theorem of calculus. So this is a most important rule to calculate area. So it gives us a beautiful simple recipe for finding a definite integral without needing complex geometric estimations. All we have to do is find the basic antiderivative, plug in top boundary number into it, plug your bottom boundary number into it, and subtract the two results. When you do this, the constant c naturally cancels itself out, leaving you with your final clean answer. C is there in both upper limit and as well as lower limit, so it will cancel out. So that is the working rule, you can say. So in this video, the discussion was very basic, and not much formula was used. Also, problems are not there right now in this video. So maybe we have to make some future videos, because this is a lengthy topic, lengthy chapter, and it's important. So yeah, so this is already explained. So how to calculate the integral, and thank you for watching. You can like, share and subscribe, and see you in the next video. So that's all for this video.